Hello, this is Chemical Reactions and Balancing Equations. My name is Piper Howell, and I will be showing off my video tutorial on how to identify chemical reactions and how to balance equations. How do you read a chemical reaction? First, you have to identify the reactants and the products. The reactants are everything to the left side of the arrow, and the products are everything to the right side. It will be our ending, and this is our start over here. So everything on this side will turn into everything on this side. Next, we have to identify what elements are in the equation. Every element starts with a capital letter. So every capital letter you see is a different element. Some elements, like barium right here, have a lowercase letter right next to it. This is still a part of the name of the element, it's just an extra letter. So molecules like sodium chloride with sodium and chloride, even though they both have lowercase letters and there's 4 letters here, there's only 2 elements because there's only 2 capital letters. Next, we have to identify how many atoms are in a molecule. The small number in the subscript is how many of that element are in one molecule. If there is no number in that subscript, then there's only one of it. So there's an invisible 1 right off to the side in there. Again, the lowercase elements, like silver here with a capital A and a lowercase g, are still part of the same name. So even though this lowercase g is attached to the number 2, this whole silver, because it's not a capital G, there's 2 of those. When you have a big line of names like this, the number applies to the element in front, right? So this carbon, there's 8 of them. This hydrogen, there's 10 of them. This nitrogen, there's 4, and this oxygen, there's 2. Identifying how many molecules are in an equation is our next step. This big number in front is our coefficient. So if there is no number in front, there's 1, because remember, we have invisible 1s. So here we have an invisible 1 next to this carbon in this methane. So there is 1 and 3 of the whole methane molecule. To tell what is a molecule and what is a separate molecule, these plus signs and the arrows are the breaks in between. So that's how you know if it's a running molecule, like these large ones over here. This is caffeine. Large molecules can get very hard to tell what's starting and what's ending if there wasn't a plus in between. So we put plus signs to show these two are reacting with each other. This is our version of the equal sign in chemistry, but equal signs are their own thing. And then these are our 2 products on this side. Further clarification, you multiply the coefficient by the subscript. So this big number in front is going to be multiplied by our smaller number behind. So here we have the molecular equation version. This translates to 2 oxygen gas, and then if we do the math, this is 4 atoms of oxygen in total. Here's a diagram drawing out each 4 atoms just to count it. So this big number is multiplied by the small number behind. Now when you have invisible 1s, remember that it's an invisible 1 right here. So this 3 times 1 is 3, so there's 3 atoms of carbon here, and when you count this out, there's 1, 2, and 3 atoms of carbon. 3 times 4, so that's 12 atoms of hydrogen, and when you count it out, there is 12 atoms of hydrogen. What is a chemical reaction? To identify chemical reactions, we first have to define the states of matter. These are small little indicators that go right behind molecules to tell you what state of matter an element or a molecule is in. So these are just little lowercase versions of the first letter of the words, and aqueous is not a state of matter, but it's still used similarly, so goes here just as an indicator. Phase transitions, these are vocabulary. You don't have to memorize all of these to know how to do chemical equations, but this is still good to know. Chemical reactions are, this is our definition of chemical reactions. They're when the reactants change into the products. There must be a change into a different substance. So here we have a phase transition. This is a liquid water turning into water vapor. And this is not a chemical reaction because the products and the reactants are the exact same, just in a different state of matter. Here is a chemical reaction because even though we're starting with the same amount of atoms and molecules, we're ending with a different number of molecules. So the atoms will always be the same amount on both sides. So we will always have here we have 4 hydrogen, and here we have 4 hydrogen, and here we have 2 oxygen, and here we have 2 oxygen. That will always be the same, but the amount of molecules and the contents of the molecules will change. Balancing equations. It's important to remember that the law of the conservation of mass states that matter cannot be created or destroyed. So we must always do a head count to make sure that the same amount of atoms are present in both sides of the equation. So here we have 1 carbon, and on the product side we have 1 carbon. Here we have 4 hydrogen, and on the other side we have 4 hydrogen. And here we have 4 oxygen, and on the other side we have 4 oxygen. So we can tell there's 4 oxygen because this coefficient 2 multiplied by the subtext 2, and here we have 2 oxygen here, and this 2 multiplied by this 1 is this 2 oxygen. And even though these oxygens aren't in the same molecule, it's still the same amount net total for the products, and so it is a balanced equation because here we have our 4 oxygen on this side and our 4 oxygen on this side, 4 hydrogen, 1 carbon, and 1 carbon. An important note is that you cannot change the subscript number, just the coefficient. Changing the subscript will change the contents of the molecule, which will make it a whole different thing altogether. So here you can see the subscript here has been changed, which made this methane molecule into an ethylene molecule. So if you change the smaller numbers, it's going to change the entire thing, whereas if you just add a big number in front, that just gives you more of the molecule. It's not changing the amount. It's not changing the contents of the molecule itself. It's just changing the amount of it. So here's an example. We have 2 hydrogen gas and 2 oxygen gas, and it is turning into water. So here we have 2 hydrogen on the reactant side and 2 oxygen on the reactant side. And on our product side, we have 2 hydrogen, but only 1 oxygen. So we need to figure out how to balance the amount of atoms because we are missing an oxygen. So we can add a coefficient to our oxygen gas because, well, if we're missing oxygen, then let's just add more oxygen. But now we have too much oxygen, and it's not equally balancing out to this water molecule. So then let's add a coefficient to the water molecule. And now we have 4 hydrogen and 2 oxygen, but we still have too much oxygen. So we'll get rid of that oxygen coefficient and put a coefficient on the hydrogen instead. And now we do have 4 hydrogen and 4 hydrogen on the product side, and those 2 oxygens are equal on both ends. So this is now a balanced equation, and we did not change any of the subscripts or the contents. We just added that coefficient on top. Let's do another. Here we have zinc and hydrochloric acid, and zinc chloride and hydrogen gas. So we have 1 zinc and 1 zinc and 1 chloride, and oh no, 2 chloride over here, and our 1 hydrogen is also 2 hydrogen over here. So we have an uneven amount on this side and that side, so we're going to need to balance this. So if we're If all of these are missing, well then let's just add more zinc, so we add that coefficient onto it, but now we have an uneven amount of zinc, and we still haven't fixed our chloride and our hydrogen. So let's get rid of that and move the coefficient over to the hydrochloric acid, and now we do have that 2 chloride and that 2 hydrogen on our reactants, and the 2 chloride and the 2 hydrogen in our products. One last balancing equation. We have sodium and water, which turns into sodium hydroxide and hydrogen gas again. So on our reactant side, we have 1 sodium and 2 hydrogen and 1 oxygen. And on our products, we have 2 sodium and 2 oxygen, and these 2 hydrogens and these 2 hydrogens will add together to give us 4 hydrogen in total on our products side. We have too much on our products and not enough on our reactants, so we're going to need to add to our reactants. So because we have the sodium is isolated on its own, and this hydrogen and the oxygen are right next to each other and a part of the same molecule, we're going to have to add to that molecule to make it, to increase this amount of hydrogen and oxygen, because we know we need 2 oxygen, so we're going to have to add a 2 to this water in order to get that 2. So now we have 4 hydrogen on our reactants and 2 oxygen on our reactants, which adds up, it equals to our product side, but we're still missing those 2 sodiums. So now we add our 2 to our sodium, and now we have an equal amount on both sides, and it is now a done balanced equation. Thank you for watching.